Hello, my dear students. Welcome back to the lecture. So, one last thing we need to understand when we're doing the column BBS. So, if you remember, whenever we used to do the BBS for the column, we had divided this L shape into two parts, isn't it? So, we used to take this straight portion once. This was my straight portion, and then we used to take this as another portion, isn't it? Right? And we knew that if you understand, we are told that this entire thing is my development length. That is from here to here. It's a development length. Where in this particular drawing, it is mentioned 57 times the diameter of the bar. Then what we used to do, we used to take the complete depth of the footing, right? And from there, we used to deduct the cover of the footing, and whatever is your shorter span diameter and longer span bar diameter, that if we deduct, we used to get this red color height. And to get the green color height, what we use, green color, this length, what we used to do, total development length minus the red color. If I do, I was getting this green color, right? And the same thing we used to do it here, right? If you follow all the pattern, if you follow it here, see 330, how did I get? The depth of my footing minus the bottom cover, then minus the shorter span minus the longer span and this was the answer which I got, which is 330. And to get this one, that is a green color here. So what I used to do, development length, that is 50 into diameter of the bar, minus this portion, minus this 330. If I do, I was getting this portion, right? Now, this may not be the case all the time. So luckily, in this particular project, and the project which I took, I told you to take this as a complete development length. Now, in some of the projects, now I'll take you one to one of the projects. See, this is also assignment problem what I had given. So here what they're mentioning, they are telling that this entire development length from here to here, you have to take it as development length, that is LD, plus 10 times the diameter of the bar. So this is a structure which is being put in the earthquake resistant zone where we need to do the ductile detailing. So that is the reason what they have done. They have given us LD plus 10 times the diameter of the bar. So nothing change will happen. Whatever development length. Now what is LD? LD is your development length, which they usually mention. Let us consider for our time being that development length is 50 times the diameter of the bar. Okay. D plus 10 into D I am supposed to do. So this will be your total development length that you are going to get. Very simple. Let us assume I'm using a 12 diameter bar. So what will be the answer? 50 into 12 plus 10 into 12, isn't it? So how much it will be? So 50 into 12 comes out to be 12 5 is 60, 600 plus 120. So this will be 720 mm, which is very simple. Rest calculation you can do, isn't it? Isn't it correct? Let me try to do it once. Yeah, 50 into 12 plus 120. Yeah, fine. It is 720. So you got the answer. Answer will be 720, and rest things will remain the same. Okay, that means you are supposed to find this height now. This height you are supposed to find first. For that, I know what is my depth of my footing. From this footing, I'll deduct the cover, the bottom cover. I'll deduct the bottom cover, and then this bar I'll deduct shorter span bar, and this you can see the round one, that is your distribution still. If you divide, you'll get this particular height, green color. And whatever height you got, let us say green color I got, I'll write some value. Okay, I'll write it as 350 mm. Fine. So the moment I get this 350, now I want to find this one, isn't it? This one. So this you can find easily. That is a red color one. This I'll take red color. How you will find? So we know this one, that this overall development length is how much? 720. So this will be 720 minus 350. If I do, I'll get it. So it is 720 minus 350. So it is 370 mm. Okay, this is also understood. So two different types I've explained you. Now I'll go with one more one. So where you don't have to take all the struggle and all. So sometimes what happens, directly in the drawing, they'll mention you the L. For example, this is one of an industrial project, what I'm taking now. So here, these people have told, so there is no development length as such. What you're supposed to do, these people have directly given you that this is L, and this you have to take it as 300 mm, finish. Directly you keep this L, this portion 300 mm. This also you keep it as 300 mm. So now you don't have to take the development length and all. This portion you can calculate, right? This vertical you can calculate from here to here. It's very simple. What you'll do, whatever is the depth of your footing, from there you deduct one cover. From there you deduct this one cover. and then you deduct the bottom steel and you deduct the top steel, you'll get this height, right? That's it, simple. So you don't have to use the development length formula. This is directly 300. Let us consider this is 300 directly given in your drawing. See, it is mentioned 300, typical. Okay. And now this height, let us say after doing a calculation, I'll do. Let us say the footing depth is 500 mm, and we are using let us say a 12 diameter bar. It is given 12 dia bar at 150 center to center spacing. Let us consider. Okay. So what will be the height now? It's very simple. So 500 minus the cover will be 50, and both the diameter of the bar is 12 and 12. So you do it, how much you'll get? 500 minus 50 minus 500 minus 50 minus 12 minus 12. So it will be 426. Finish. 426. So this will be my 426. 426. Now you don't have to worry about that 57 times the diameter of the bar or the development length. So this is one more case. Okay. So don't be under the impression that all the time you have to use the development length. It totally depends on the structural drawing that is given to you. This is also one more drawing where they have given this is my typical. But in some of the drawing, they directly give you. There is no typical and all. They directly give you like you have to take 57 times the diameter of the bar. Then you do it accordingly. Here it is given. If you check this drawing now, here there is no such thing like 300 mm. This overall is 57 times the diameter. So totally we have three different cases. One is only a development length. Sometime in a earthquake resistant structure, they give 57 times the diameter, development length plus 10 times the diameter. And in some of the cases, they directly give you, take it as 300 mm. Okay, like this here also they have given 300 mm. So directly they'll say put 300 mm, and based on that you have to do it. Okay, so look into the drawing what is given to you. Based on that you have to do the calculation and you have to do the BBS. Rest things remains the same. There is no much difference. Okay, and other than that, in the previous lecture I explained you about how it has to be done. Suppose see here, if I ask you to do the BBS, you can do. It's a 16 diameter 6 bar. And if it's a G+3 structure. So in ground floor, first floor and third floor, everywhere you will do 16 diameter 6 bar. You have a BBS ready. But if you look here, it's a 20 diameter 4 bar and 16 diameter 2 bar. In that case, 20 diameter 4 bar BBS you'll do first. And then 16 diameter 2 bar, this BBS you'll do after that. So you'll use an Excel sheet, something like this. 2 times you will do. This is case number 2. Sometimes what will have, you will have a G+3 structure, but maybe from up to the plinth and first floor, you have to use a 20 diameter 4 bar and 16 of 2. And only in the terrace portion, you'll be using a 16 diameter 4 times. So in that case, then you need to change your Excel sheet according to that. Got it? Yeah. So I hope you have enjoyed my lecture up to here and you have got a complete idea how the column BBS has to be done. Your fundamentals should be strong, where the first method I have explained you. Rest all things will be a small, changes which you are supposed to do based on the drawing. So we'll see you back in the next lecture. Thank you.